The word lifespan is kind of like the time from the beginning to the end.
The brain is developing during the in utero, and then it's continuing to developing throughout the life.
Childhood is very important.
The impacts that you have on the environment and some of the legacy that you leave behind.
Say when you start going to school, from there until you retire, when you're actually in your prime active and functional time.
Poi poia te kākano, kia pua wai. We need to nurture the seed in order for something to flourish and to grow and flower.
So I guess te haerenga o te tangata.
Hi, I'm Elodie, I'm Desroziers and the Department of Physiology. I'm working here at Otago on polycystic ovarian syndrome, which is an infertility disorder in women. And this syndrome can act during puberty, but also during adulthood, making the woman not being fertile and having trouble to have kids. This disease is that maybe an androgen exposure in utero is playing a role in that. So we are using a model which is exposed to androgen in utero, and then we are trying to decipher what this androgen exposure is doing into the brain that make them infertile at adulthood.
Tēnā koutou katoa, ko Indranil tōku ingoa. I work with this awesome team based in the Department of Biochemistry at the University of Otago, led by Associate Professor Stephen Hughes. We have PhD students and postdocs and research fellows working towards a mission which is basically finding a cure for a childhood brain disease called Batten disease. The effect of the disease on the children as well as the family as well as the society, it's just unimaginable. To find a cure, we need to know what's going wrong. What we aim to do is we want to know the function, and that way it will be easier to treat. We are using a very unique model. It's a cell model, and we call it human brain in a dish, or human brain cell in a dish. So what we did was we took skin cell, and we added some factors to that to the skin cells, which was turned into a stem cell. So we started growing neurons, which are the brain cells, in a dish from these pluripotent stem cells. The neurons, if you think about them, they are growing on a dish which is like a 2D platform. Our brain is not 2D, however, it's a 3D model. So to mimic the human brain, what we are doing using the pluripotent stem cells is we are growing mini human brains, which are known as brain organoids. We are actually using those mini brains to model one form of the Batten disease.
Hi, my name is David Bilkie. I'm a professor in the Department of Psychology at the University of Otago. So my team is really interested in schizophrenia, in particular the changes in the brain that occur that affect cognitive processing and memory. We're looking at some of the changes that occur in the brain in a model of schizophrenia. Well, one of the interesting things about the model that we're using is that the initial manipulation occurs while you're in the womb. But the effects don't occur until you're an adolescent or an early adult, and the effects can be quite devastating. And so it's really quite remarkable how these events that occur very early on just changes the way that the brain develops, and then suddenly you have all of these effects occurring, all these symptoms occurring as an adult.
Kia ora, ngā mihi ki a koutou, ko waiau, ko tainui me te arawa na waka, ko Ngāti Maniapoto te iwi, ko Louise Parr-Brownlie toku ingoa. So hello, I'm Louise Parr-Brownlie and I'm one of the researchers, the people that lead a research team within the Brain Health Research Centre. I do not do this job alone, I have a team of 3 postgraduate students and 3 staff who conduct a lot of the research, the bench research alongside me. So Parkinson's disease is caused by loss of a small group of cells very deep in the brain, and they produce a chemical called dopamine. When those cells die off, it affects how messages get conveyed through what we describe as movement pathways or motor pathways, and as a consequence of that, people end up with movement disorder. So one of the things that we've been working on is looking at the next generation of a treatment that's currently used called deep brain stimulation. So for this, a probe is placed into a person's brain and the brain is stimulated, and patients find that really helpful. For some patients, they end up with side effects, and so we're looking at developing new technologies to reduce the side effects. And the way that we do that is that we use light to stimulate the brain, and we can control exactly which groups of cells in the brain we control or activate, and therefore we aim to be able to reduce the number of side effects that the person experiences. So one of the things that I realised about 3 years ago was that the research that I'm doing, where we look at putting probes into the brain in order to stimulate the brain, would not be seen as appealing to my ancestors. So I actually stopped and had a wee think about what I was doing and how I was doing it, and realised that I needed to take a step back in this research journey in order to be able to consider how I might be able to help my own whānau. So one of the projects that I've done since then, we have been working with 2 Māori communities, and we've been asking these members of these communities about their perspectives of how we as Māori have always kept our brains healthy, if people have lived through a situation where brain health has been compromised, what they've done in order to get healthy again, and understand the experiences that they have, these whānau have been having. It has been a wonderful and enriching experience. I have an incredible research assistant that's been working on this project, Mariana Tapau, and we are still gathering the information and understanding exactly the research that we've got, and we hope to be sharing that in about another year.
Kia ora. I'm Stephanie Hughes. I'm the Director of the Brain Health Research Centre here at the University of Otago. We wanted to encompass the whole range of research going on in the Brain Health Research Centre, and to do that we need to cover everything from pregnancy and motherhood right through child development, teenage and adolescent years through to normal adulthood, diseases that strike especially in late adulthood and the elderly, and also to encompass normal healthy ageing and how we might be able to prolong a healthy lifespan.